Hey guys, welcome to another video. Today I'm going to solve the weekly contest of 482. So before I solve this, I just want to say that we had our OA and there were a total of 3 companies. The first one, the first one I wasn't eligible to sit because I don't have that much CGPA. The second one I got to sit, but yeah, they only took 4 people from the campus. Yes. So yeah, there, and I wasn't even selected in the OA because I believe a lot of people have cheated in online assessment. That's what I believe, but yeah, I cannot say anything more about that. So now it comes to the Google OA. So there was the next company, which was Google, and in that way I was thinking that I might be able to do it. So there were only 2 questions, okay, and one was of sliding window and another question was of using a stack, right? So they were pretty easy questions. They're very easy, like it's the when you first time learn stacks and sliding windows, those are the questions you solve. So it was very easy, and not only that, for a lot of people the OA went easy, and I heard like a lot of people actually had the same question. There were only, like, as far as I know, that there were only 4 different questions, and people were just getting the same questions repeated over and over. So the same question of sliding window, and that my other friend also got the same question, and there were only 4 different questions. And people also took people took a photo of all the questions, and that's what I totally guessed. Like right now there were only 4 different questions, and there were no other questions that I have seen till now, right? And it was like 2 days ago, and so I'm sure that there were only 4 different questions, which was a very small pool. Okay, so everybody thought the OA will be easy, and yeah, they were probably going to say shortlist from the resumes. So because the thing is, I have completed the online assessment in only 9 minutes. My friend, who had also completed it in almost like 8 to 9 minutes, we both were not selected, but there were some other persons, one of my other friend who did it in 11 to 12 minutes, and there were some other friends who did in 16 to 17 minutes, and there was this other guy who also did it very late, he did it in 26 to 27 minutes sometime, and the 3 of them got selected for the interview. Yeah, my friend just had an interview at 9 a.m. and I have not really asked the guy right now, because the interview might be long. I'm still yet to find out, so I'll try to solve that questions which was asked to him as well. Okay, so my main point is, so they didn't select on the basis of the OA, right? There were some so these were the friends which were confirmed, okay, and they might be lying but I don't think they were lying. But so I can assume that these are confirmed that that like they didn't consider time as the thing. The OA was just I don't know what it was for. Why did they even take OAs if they had to sort list from the resumes? Maybe the other case can be that they were trying to see if anybody cheated or not. Like maybe they flagged me and my friend because we have completed it so fast that they flagged us cheating. Like you cannot have this was impossible, right? That can be possible to do it in like 9 to 10 minutes. Okay, so maybe they thought that it was impossible and we couldn't do it, and they flagged us as cheating. This is one possible, or the other possibility that they just took the OA for I don't even know why did they take the OA. So and some of my friends also said that there were some guys who didn't even have solved all the 2 questions, and he got selected for the interview. Okay, so definitely the time wasn't a thing because of 2 reasons. Maybe cheated, or maybe OA was just there can be anything, right? Okay, now let's talk about resumes. Maybe resumes also either there can be 2 things, either time, so it's definitely not time, then maybe time, cheating, and resume. I have no idea. So talking about resumes, there were some people that I heard, it's just a speculation, I'm not sure of it, but if I talk about the the resumes, there were some people speculated to have a very very bad resumes, and they were also selected in the interview. And this is just a speculation, I don't know about this, but I'm 90% sure about that, like what I just told you about the time factor, that my friends were selected in the interview and we were not. Yeah. So they were really to be honest, some of my brilliant friends, they were also not selected for the interview, even though so the thing is that I have really grinded a lot, like everybody did, obviously everybody has grinded, but there were some other people who were non-deserving as well. They got into the interview. That is what is heartbroken. Like I have put in so much effort for this 1 year doing DSA, and there were other people as well who were also putting. There were some of the people who has put the real hard work and actually got selected for the interview. I'm happy for them, but there were other people as well who didn't actually work hard. It might be all about smartness, maybe. It's not just the amount of hard work you put in. It just that how smart you are in the end. That's what actually really matters, maybe, because hard work is just there are a lot of person who do hard work, right? You just have to be a little smart, Maybe that's the case. Maybe resumes was all, but I'm not 100% sure what was the actual thing that was happening. How are they shortlisting? I have no idea. Anyways, so yeah, this is today I'm going to solve this question. Okay, so let me keep my laptop. Let me fix the posture of my laptop. Then yeah. Okay, all right. So let's try to give the virtual contest and see how many I try. I just try to solve all 4, but I never end up solving 4 of them. Like, it has never happened to me. Okay, so you are given an integer array nums, which is this guy, of length n. Choose an index I such that, yeah, for a chosen split I, let prefix sum be this and suffix sum be this. Alright. The score of a splitted index is prefix minus suffix, prefix sum and suffix min. Yeah, minimum value among. Yeah, alright. The score of a split index is defined as this thing. Okay, return the integer denoted in the maximum score over all valid split indices. Right. This is, I think this is quite easy. I think the what you need to store is just the suffix minimum and nothing else. So yeah, so that's what you need to store. So let's try to store the suff and maybe I can do n+1 here, and n which will be nums.size. Okay, and now okay, so suff of n-1 will be nums of n-1, correct? The minimum, actually the minimum of n-1 will, I don't know what it is going to be, because if you are at this index, you want to find the minimum at that +1 index. So yeah, so maybe for here, if you look at I equals to 0, they split, and we cannot check for I equals to n-1. So yeah, we are safe on that. So we don't have to check for n-1. Yeah, so I don't need to care about that. So what I will care about is that n-2 is nums of n-1. That's what it's going to be. And from n-3 I'm going to do this, minimum of suff of I +1, nums of I +1. Okay, right. So now I am going to make a variable of sum, which is just going to store the sum from the prefixes, from the first indexes. Okay, so I'm obviously not going to go till the end, because as we can see, it's just the index is maximum where it can go is n-2. So I'm going to do this, and now I'll do this, sum equals to nums of I. Okay, so as you can also see that the thing is long, so maybe the sum should be long, and yeah, I'm also going to store a maximum, which will be initially minimum. Yeah, so now I am just going to do this, comma sum minus suff of I. and then I'm just going to, okay, before I try to do, okay, yeah, it's all right, and then I'm just going to return the maximum of the answer. This should work. This is 17 minus 2, yeah, and 0, which is working fine. Yeah, it got accepted. So let's solve the second question. The minimum cost to acquire required items. So there are a lot of variables. You are given 5 integers, cost 1, cost 2, cost both, need 1 and need 2. No idea what are these. Okay, there are 3 types of items available. An integer of type 1 costs, yeah, integer of type 2 costs this, and okay, so the first item is type 1, which is cost, which is given by this, right? The cost is given by cost 1, and it contributes 1 unit to the type 1 requirement only. So yeah, I think something is happening, and cost 1 is related to only type 1. Cost 2 is for only type 2, and cost both is type 3, cost of the item 3, in which just means that this will contribute both to type 1 and type 2. So this is for both of them, that's why it's written as cost both. And we have something need 1 and need 2 as well. And what are these? You must collect enough items so that the local contribution towards type 1 is at least need 1. Okay, yeah. So if I buy type 1 once, I'm just going to be filling up, need is just going to be so need is just going to be decreased by 1. So I need this many things, and each of the need 1 actually cost 1, and for need 2 as well, if I buy this, only this is going to decrease, correct? Only this is I'm going to only fill for this is not going to change. But if I try to use the type 3 cost, I'm going to end up filling both of them. Yeah, I'm going to end up filling both of them, and that might be something which might be better. So the first thing that I'll say is that if cost 1 plus cost 2, it's lesser than or equal to cost both. So the thing is, cost both is lesser or equal to cost 1 and cost both, then what I'll do is, so let me create a sum variable here, which will be long sum, and whenever this happens, I will I'll do this minimum of need 1 comma need 2, or maybe let me write this, x is equals to minimum of need 1 comma need 2. Okay, and now I'm just going to add this, plus I'm also going to add I'm going to add this times cost both, right? And I'm going to add whatever is left, so cost 1 times need 1 minus x plus cost 2 times need 2 minus x. This is what is going to be if that's not the case, if this is smaller, then I'm just going to count them individually rather than together. So sum is just going to be cost 1 times need 1 plus cost 2 times need 2, right? And then I'm just going to return the sum, and I think this will do it. Okay, my output was 5. I don't know why is that, because we can see clearly that cost 1 and cost 2 if I add them up, we can clearly see it's greater than or equal to cost both, right? So after buying 3 type 3 item, which was this, the total contribution to type 1 is where what? So I'll buy this 3 times, cost both, type 3 times 1 and the type 1 is 3 times, which is okay. Okay, correct, right. Maybe I should not do this. What I will do is a little bit different. So yeah, even if this is the case, so what's happening in the test case is that I'm assuming that if some of the need 1 is lost, I cannot use, let's say need 1 is 0, so I cannot use cost 1 or cost both. That was my assumption, but seeing the example, my assumption is actually wrong. So we can use this as many times as we like, as much as because I just need this much, I just need this and need 1, right? But I can collect more of the values than need 1. Yeah, so I'm also going to have to check that, okay, this is the thing, I'm just going to do this, but also if cost, let's say cost 1 is greater than equals to, or maybe less than cost both, and then cost 2 is also less, like greater than equals to cost both. So when you have these kinds of situation, what is better is just to use this always instead of using this, because it's just anyway going to be greater, right? So sum plus equals to cost both, and I really don't want the minimum, right? So maybe I should not do this currently. Yeah, so what I'll do is just the maximum of need 1 and need 2, right? But if this is not the case and any one of them is lesser, okay, so if any one of them is lesser, let's say cost 1 is greater than equals to cost both, or cost 2 is greater than equals to cost both, then what will happen? So this means that the cost 2 is actually lesser than cost both, right? So so the thing is, after I try to do this, if I have need 2 which is left, then I'll be using cost 2. But if there is need 1 which is left, then I'll be using cost both again. That's what I'm going to use. So yeah, so if this is the case, then I'm going to use cost both always. If this is the case, I'm just going to use cost both for need 1 but not for need 2. So anti-x, I'm going to do it again, need 2, and I'm only going to do this. So let's say cost both, and then now if cost 1 is more, so now after doing the need 1 is still more, then I'm still going to use cost both. So need 1 minus x, right, times cost both. This is what I'll do, and I'm also going to add need 2 minus x, but because need 2 is lesser than cost both, I'm just going to do cost 2 for this one, right? Similarly, I'm just going to do the same thing for this, but instead of need 1 here, it will be need 2, and this is going to be need 1, and this will be cost 1. Yeah, and this is fine. If this is not the case, cost 1 and cost 2 added both are lesser than cost both, then I'm just simply going to do this, because it's always going to be lesser, and I think this should work. So yeah, it worked for the case 1, it worked for the case 2, and it worked for case 3. So let's try to submit this. So I got a wrong answer, I don't know why. I have cost 1, cost 2, cost, okay. So we can see that that adding these two, okay, yeah, I forgot about the other case. So else, if both are lesser, right, cost 1 is less than cost both, cost 2 is also less than cost both, then I'm just so maybe I should not do this. Instead I'm just going to do this, and but still if that still happens, that cannot happen, right? Cost 1 is less than cost both, correct? Cost 2 is also less than cost both. So maybe I should not use this. Instead I'm just have to use this. This is the case. If this is the case, if this is the case, then what? Right, and I will be sorted. So yeah, it's same. Yeah, so there were some mistakes that it's again wrong. Why is it? So I already got 2 penalties. I've made almost all the cases, right? Yeah, so the thing is, if you look at this, there is a mistake here. because okay, so for these cases it's alright, but for this one it's actually not. This is alright, okay, and this is also alright, but even if they are lesser, the cost both can be greater as well. So I need to add one more cases that I forgot, which is like if cost 1 plus cost 2 is greater than cost both, even if they are almost similar, like let's say they are equal. So the cost 1 is lesser, cost 1 is lesser than cost both, cost 2 is also lesser than cost both, but they are still similar, then I am obviously the most probably I'm just going to use cost both. But if they are cost both is greater, then I'm just going to use them individually. But if cost both is lesser than or equal to, I'm not going to use it individually, correct? If I added them up and it's equal, so this is just going to be x times cost both plus need 1 minus x times cost 1 plus need 2 minus x times cost 2, correct? Yeah, so yeah, it had a lot of problem. 316, yeah, so what is correct? 2, this should be 0, this should be 22, and this should be 3, right? Okay, now what? Yeah, so lot of penalties today for some reason. What's the wrong? Okay, I need to convert this to long, so maybe this will okay, so instead of changing this to long, I think I should change this, right? Everything will be fixed. Yeah, need 1 and need 2, I don't need to change it because they are always multiplied by cost 1, which they are going to change. Yeah, so yeah, I think so much, 3 penalties already. Alright, that's not a big deal. So now we are given a positive integer k, which is this, and we need to find the smallest integer n divisible by k. So smallest integer which is divisible by k, that consists of only digit 1 in its decimal representation. Okay, right. Well, how can we do this? So smallest, so obviously the smallest number n which is divisible by k is going to be greater than equals to k, right? And it should, this is always the truth. So I need to search for the elements which are greater than n, right? And first, before I do that, I'll have to figure out when 1111s, like what are these divisible with. For example, if I'm talking about 11, so it's just divisible with 11 itself, so k must have to be 11. So if it's a prime number, you cannot just do anything. But if it's not a prime number, yeah. So what I'm thinking is, like, let me see the constant. Yeah, k is less than or equals to 10 to the power 5. So what I'm thinking of, like, using maybe sieve to do the things, like if I have a really large value, let's say the large value is how much this is, 1 2 3 4 5 6, let's say this is the answer, what will be its k? Yeah, k must be just the number which is lesser than this and divisible by it. Or maybe I can just brute force, like in log n time. That's pretty good, right? So I just need to check for 1 2 3 4 5. So there are only 5 elements at max that it can go, and I try to convert it to string and then try to do, yeah, I think it's very simple. And because, as you can see, the solution is of int, so it's quite easy, I think. So let's try to create something like int x, which is 1, and I am going to, yeah, what I'm going to do is int answer, which is also 1. Alright, now if answer modulo k is equals to 0, then I'll return. So as we can see, it's up to int. I can just check x until x is greater than 9, maybe 10 to the power 9. The answer can get very large, and yeah, log n is alright. So return answer, else okay. So what I'm going to do is while, or maybe not while, maybe yeah, while is correct. While answer modulo k is not equals to 0, yeah, and if this is truth, and x is, yeah, so I want to check until so this is a power of, if you look at this is a power of 10 to the power 0, and I want to check till 10 to the power k equals to no, k is already there, count equals to 0, and I want to check until 10 to the power 9, maybe, yeah. So right now count is 0, and I want to check until count is 10, right? This is alright. So yeah, so now what I'm going to do is right, so yeah, if this is the case and this is also the case, then the first thing that I'll do is increase the counter. I'll increase the x, yeah, answer will be just x plus, right, and just check it. So if answer modulo k equals to 0, then I just return answer, else just return -1. So I increase the counter, I increase x. For the first time when it is divisible, I just, perfect. This should work, I don't know. Okay, sign integer overflow, so I cannot do this. What k equals to 3, k equals to 2, this is 0, so I think I need to reduce the counter by maybe 9. Cannot multiply 10 with 9. Why is it unable to multiply 10 9 times? Like, why not? 1 2 3 4 5 6 7 8 9. Okay, maybe 8. Yeah, it is working fine, I guess. So let me just, wait, what? Expected 3. Oh, okay. I didn't check. I thought I needed to, yeah. Alright, I need to just return the count instead, not the answer itself. Okay, so count was 0, which means there was only this thing. 1 means it is this, 2 means it is here. So I'm just, and then okay, for a particular count, let's say it actually got accepted, so I need to this. Yeah, so today I am getting so many penalties because I am not checking everything correctly. Yeah, I think now it should work. Okay, right, 16. Yeah, okay. Okay, so when this is the thing, it actually makes it even hard. So 5 penalties, I already got 5 penalties. So yeah, because I needed to return this, now it becomes a lot harder actually, because now the logarithm won't work, because it can just go as large as an integer value, and there can be a long chains of 1 as the answer, which, yeah, so I need to change my thinking now and try to generalize this. I thought this would work because of log n factor, because if I only wanted to do this, but yeah, so I need to do something, come up with something different, because yeah, so I just need to somehow try to, k is there and there is a lot of 1, so if I try to divide it by k, what's really going to happen? That is what I need to find out. I obviously cannot do digit db because it can go as large as 16, something like that. Yeah, so for 1111 to be a multiple of k, it should be a multiple of k, right? So when can just 1111 be multiple of k, like it should be either like k can be anything. So one thing is pretty sure, that if you want this to happen, the k should be, if you talk about primes, right, k can be 3, k can be okay, k just can be anything, man. I will have no idea how work out this one. Right. Trying to think how can I solve this problem. So yeah, maybe if it's all just the same. So what can we actually do about this thing is what I'm trying to think. So let's say our k is divisible by some 1 ones, right? So now will it still be divisible by 1 1 1? If it's divisible by this thing, is it still going to be divisible by this? It depends on k, right? We don't know. We really can't say. If it's divisible by this, then it might not be divisible by this. But the thing is, if this is the minimum that it is divisible by, then we know that this whole thing will not be divisible. And for it to be divisible, you need to have one more 1 1 1 1, right? This many numbers you need at least. So yeah. Yeah, so what can we do? So the first thing is, how do I even know if what is the property that this has, only 1 1 1 ones actually has? So first of all, if k is a multiple of 5, I won't be able to do it. Correct. K is a multiple of 10, I won't be able to do it. Right. If k is 11, then I could do it. If k is a multiple of these guys, then I can do it. But what are their factors? That's what interests me. So k has to be a factor of these guys. K has to be a factor, and when I divide it, it should give me a number, and it should divide. So the remainder, what I get, let's say when k is a 3-digit number, so if it's pretty hard to think about. So can it go to 16? But it can also go to int max, or maybe not exist at all. Because it expected is 16, so it can actually go much worse. The case can be a lot worse. Even if I try to do long, it might not be able to handle, because for k equals to 17 it got so big, like 16 ones, and then you will be able to do what you want. When actually can I do this? How many ones do you need so that this is going to be divisible by something? K is actually this tremendously large thing that I'm fearing. So how do you even make it multiply so that I'm multiplying k with something which after multiplying it I am going to get a lot of ones. Okay, yeah, that's really for, let's say, for 17, how can I get a 1 in the end? So for if we talk about this unit splits digit, I can get a 1 after I multiply it by 3, right? Yeah, so when I multiply it by 3, I get a 1. So let's try to figure this out. So when I multiply 7 with 3, I get 21, correct? 21. Is there multiple ways to get 1 from 7? No, right? There is only, if you multiply it by 3, that is the minimum which you can get, so that the last digit is 1. Or if I try to maximize it, then it's not really going to be fun, right? When you try to do multiply, and then you're just going to get a 51, and now what you're going to do? You are just stuck again. You need to multiply this 5 here with something. So now the thing is that you can multiply this whole thing with a lot of ones to get what you need, correct? After you multiply 3, you get this, and then now you can multiply a lot of ones. That's it. The last digit must be 1, but the first digit it's not necessary, but you can actually also try to multiply it by 11 maybe, because when you try to multiply it by 11, or maybe 7, maybe 3, 4, 5, anything, if you do anything, then it's not actually going to be. But so you need to come up with something different, correct? Okay, yeah, I have no clue. Maybe this thing will work. I just need to make the answer, this one long, maybe, but it's already tremendously large. I don't think long is going to help. So how do we even do? Okay, let's try to do the fourth question maybe. Yeah, so you are given two integers, low and high. An integer is called balanced if it satisfies both of the following condition. It contains at least two digits. Okay, yeah, so it's balanced only if it contains at least two digits. The sum of the digits at even position is equal to the sum of the digits at odd positions. The leftmost digit has position 1. Yeah, okay. So 9 times 15 is how much? Can anybody answer? What's 9 times 15? It's just 150 minus 9, right? Which is 141. So yeah, it's totally fine. Yeah, so how can we do this now? So return an integer representing the number of balanced integers in the range list. Alright, so yeah, so let me try to do this. So let me try to make a function which will give me that. So maybe long f, which is going to take the string s and idx going to be the first indexes. Okay, now what I'll do, I'll just try to add at even indexes, add at odd indexes, and if I see that I cannot make something, then I'm just going to do dp, guys. So this idx is going to be representing the first that occurs, and I'm also going to represent bool tide, which is going to represent if I can use all of the integers from 0 to 9 or not. And also I'll leading 0, which is going to tell me if I have leading 0 or not. If it's 0, then I don't have leading zeros, and then I'm okay. And but not only this, so this is going to be 15, this is going to be just booleans. I am also going to have to according to the index and all of the things, I am also going to try to get the sums correct. So anti sum 1 and anti sum 2, which is really just going to be maybe I can do something. Yeah, I think this is all right. So yeah, this is all the things. So the sum at max can be, it's not going to be more, someone is not going to be more than 9 to the power 7. Sorry, 9 times 7, which is 14. This is also not going to be more than. So it's just going to be almost 14 times 14. So let's say it's 20 times 20 times 2 times 16, which is very small. Yeah, so yeah, let's try to do it. So first of all, what I'll do is, if I want the upper bound, which will be if it's tight, correct? Okay, so if upper bound and I see that it's tight, so I only have to use the maximum character that this particular index have corresponding to this string. So I can only use that. Yeah, or I can just, if tight is false, then I'm just okay to use an anti-lower bound. So lower bound is, it can be, it's just can be 0. You don't need to care about this one. Alright, now what I'm going to do for anti-dig from lower bound to digit to upper bound. Okay, so what am I going to do? Okay, so the sum will be initially 0, and I'm just going to add the sums until I get to the point where index is just equals to s dot length. Okay, alright, so now I am here and I am trying to do this. So yeah, I am always going to add 0 if index okay, so if index is 0 at the odd places, if the index is at the odd places, I'm going to add 0 to them. If the index is at the even places, I'm going to add here. So yeah, first of all, what I'll do is, so for this digit that I have in LB, I need to return to the sum, right? Long, let's say, let me create the sum, which is 0, and I'll try to return that thing over here. So f of s idx plus 1, and tight is only going to be if it was previously tight, and digit is equals to upper bound, then only this will be tight again. And for leading zeros, if it was already leading 0 before, leading 0, and digit is also a 0, right? If leading 0 was already true, there was leading zeros, and digit is also 0, then I am again going to have a leading 0, right? And now in this sum 0, what I'll just add the digit, okay, digit time index and 1. So if index is really just, the index is 0, so odd positions, the leftmost digit has position 1. Yeah, so if the idx has is divisible by 2, then I am at odd position, right? Not even, because it's starting with the 0th index. And so I am going to add this to sum 0. So also I am going to, sum is not going to be more than the speculated 14, right? So it's okay, so it's okay to do this. And digit times idx and 1. So if this is 1, this is it's going to add here. If it's even this, if it's yeah, so if it's odd, then I don't want it to add on both of them. So yeah, I'm just going to do this thing, correct? So this will make sure that only add this digit to the sum 1. Yeah, so only add this digit to the sum 1 if idx is at even position, but if it is at odd position, add the digit to sum 0, right? This will be only 0 until 1 and so on. And yeah, if digit itself is 0, then I just add nothing. So yeah, so now I'll try to add this to the sum. Yeah, I think this is alright. Sum. So yeah, the thing that I will do is in a string s1, which will be to string low, and string s2, which will be to string high, correct? Now I just need to return yeah, so if in the end s dot size is equals to, or maybe s dot length, whatever is fine with you guys, is equals to idx, then I'll return sum 0 is equals to sum 1. Yeah, if this is true, then only I add it, else I don't add it. This is alright. And there is one more thing that I'm not taking care of, which this one, right? So I need to take care of this as well. Okay, so low is really going to be less than, and high can be anything. So yeah, so for like if I am talking about if so if I'm at the end and the number of digits are, maybe I can add one more constraint here about the number of digits, I think, or maybe I don't need to care about that because I can handle it tens at least 2 digits. Yeah, so let's say if hash dot length is lesser than 2, then I just going to add 0, correct? But if it's even if it's more, I just want to have, maybe I should just add one more thing, which is anti counter, which will be initially 0, and as soon as I am increasing, I'll only increase the counter if I encounter a digit, correct? So Yeah, so encountering a digit will be like if it was leading 0. Okay, and digit equals to 0. So let me try to create this bool variable, bool 0, which is just this thing. Okay, and let me undo these things. Instead of this, I'm just going to add 0, right? Not to do so much. So if it was 0 already, which is there is the whatever you are doing is actually having 0. If this is false, so if this is false, then counter plus 1, else just do nothing. Because if you are still at a leading 0, yeah, if you are still at a leading 0, right, I mean, yeah, if you are again just not adding anything, so you're just going to, but if you are not at leading 0, like this is false, then you are adding something else and just do this. Yeah, I think this will work to count the number of digits. So count greater than equals to 2 and someone is equals to this, then only I do that, else I'm just right. I think this will work, so let's try to do this thing. S2 0, initially type will be 1 because you cannot have, and leading 0 is also going to be 1, right? Sum is going to be 0 0, count is also going to be 0, and it's the same thing I'm just going to do for string 1, I mean. Yeah, so let's see if this is going to work or not. So it's working fine, as we can see. I just need to add the dynamic programming here, so let's try to add it. So yeah, maximum string that IDX can go to is obviously 16, right? So if you have a 16, then it's going to be 0 to 15. So I need 17 at least. Yeah, and tight is, these are just boolean values, so it's not a big deal. Sum, okay, so the sum for the even indexes is not going to be more than 7 times, 9 times, which the half of 15 is 7, so let me consider, let's say 8 for some reason. So the maximum that some 0 can get is 7 times 8, which is 56. Yeah, right, 7 times 8. So let me do it, 56. So this alone becomes 10 to the power 4, 10 to the power 5, and then count is just going to be again same thing, 17 or maybe 18. So this whole thing actually becomes almost 10 to the power 4, 3 here, 4, 5, 6, maybe 7, I don't know. So memset dp, yeah, these are going to be all long, correct? Yeah, so memset dp, I don't know if this works for long or not, but let me anyway do this size of dp. So first I'm going to do this long and one will be, sorry, yeah, this thing long and 2 is just going to be, I'm going to do this again. Yeah, and then I'm just going to do as 2 minus as 1, and I think this will do the thing. Yeah, also I need to check for this, if dp of idx of tight of lz of sum 0 sum 1 and count is not equals to -1, then I just return this whole thing, which is a little too much. Right, yeah, let's see if this works. 2 1 and 9, this is working. Yeah, it has given me a wrong answer, I don't know how. Oh yeah, the thing here is the mistake that I did, because I need to have this thing. Yeah, yeah, so let me submit it again. What happened? 56 is out of bounds. How is this possible? This cannot go beyond. All right, so let's try to improve this. 9 times 8. Okay, 9 times 8 it will be, let's say 100. 4 5 6 7 9 times 8 is 72. Today I have got a lot of penalties. I don't know if I will be even able to make something or not. Let's see. Yes, let me submit again. I hope this time it works. Time limit exceeded. What? How? Yes, so there are 15, literally 15 variables here. Maybe I can remove this count function and try to count it manually for, right? From 10th, right? Okay, yeah. I think from 0 to 9, I think we need to do it for, we need to subtract it for ourselves, right? For example, here, high, whatever is high is, and low, low -1 is something, and I'm subtracting this. Okay, so for a particular high, let's say I'm trying to find the maximum between 10 and low one, and similarly for here of 10 and high, correct? And I'll also try to find out for string 3 7 9 7 7 7, that can be 73, which is right. And here I am going to find out for string 9, right? Or maybe something like this. It's going to, yeah. So I'm going to do this 2 times or 3 times. So for these things, how many, from 0 to 9, how many times will I be adding? This thing will make sure that I always add from 9, right? Maybe this. So this thing 9 will make sure that you always add from whoever is higher, like high or 9, whoever is more, you need to take that. Like let's say this is more, so I am anyways going to find out how many times this is going to happen, 9. So, and then I'll just, it is just going to be how much? So when there is only one digit, let's say only 9, right, then one sum will be 0 and this is one sum will be bigger. Only for 0 it's going to be different. So I don't really need to add this count here, correct? So let me reduce it. And do I really need to have this sum as well? Can't I just find the sum altogether and subtract it by some 0? Yeah, I can do that, right? I just do the sum f sum here and just reduce it more. Just have to do with this, deal with only one of them. I don't need this and I don't need this. Yeah, now I'm good. So these two are gone. Again, these two are gone. These two are gone. Actually finding, as you can see, low is from 1 to 0, so I will try to find from 0 and yeah, I don't need to do these things, correct? There is always only going to be 0. That will make things unhappy, so let me also not do this. And because someone I'll be like, okay, f sum minus sum 0, if this is equal, then do that. And talking about sum 0, I can see sum 0 is alright. I'll reduce it to a lot. I hope this will work. Yeah, so I reduced 2 of the values, but I also increased the total f sum, which will be, f sum 1, which is 0, and for char c in S1, okay, I don't think this will work, because, okay, let me try to think, because even if you have total sum, you are also doing this sum. This means something different. Yeah, the even places and odd places, yeah, so you actually need someone as well. You cannot eat it. You need that someone. So it's just, yeah, you cannot just eat that thing, you have to have it actually. Yeah, so I made some mistakes, right? This will be not not right, quite good. You have to have it, or else you're just doomed. Yeah, you don't need this. Have some. Yeah, so the thing is now is it's quite great, and if you are talking about this, it will be 0 0, right? Yeah, this might work now. Bull 0 zeros, and these things, this is obviously not going to be more than, I hope so, it's not going to be more than 100 into 100 into the power 675 ish, and for each of them I'm also doing this, so I don't know. Yeah, so I can just do this answer 1 minus answer 2, right? Because for both of them it's just going to be similar. 9 1 0 2. Yeah, it's working. Maybe I should submit it now. Yeah, finally. Yeah, so I have a lot of bad things today, even though I solved the last one. Yeah, okay, like digit DP is really a very common. Now for this one, this is the only thing that's currently bothering me. Maybe I should try to do long and try to think about this problem, or maybe something that I don't know about. What does 11 have to do with some number which is divisible? Okay, so if you have 3, then you can have 1 in the end. For 4, I don't think you will ever have. For 5 also, I don't think. 6 also, I don't think, because it's a multiple of 2 as well, so 6 will not. 7, yeah, 7 3s are 21. This can have, and 9 can have if the last digit is, yeah. And nothing else. So I only need to check for these values, correct? So now what can we really do? So like, let's say I am having 3. What will make it a 21? Like, I can maybe try to multiply 3 1 3 2 just 6, 3 9, 3 4 12, 3 5 15, 3 18, 3 7 21. Yeah, 7 might do the work. He'll say, okay, it's 21. Now I need to make this value 1. Can I make it? Well, I need to multiply this also with something, right? Where the end is going to be something like 1, and the beginning is going to be something that I don't know. So maybe if I write 7, then it will be 7 14 7. As if you look at this, it will be like, if it's 2, correct? (71 times 2) still not. It's quite. Maybe I should just do a long. How many? So many of them have submitted this, and I'm not able to think about this problem. Okay. Quite hard. It's not hard actually, I think. It's just that I am unable to think about this. I literally have no idea. Maybe one thing at in the end we can do is just whatever I have submitted previously, I just do long. That won't work. Most probably this won't work, but let's still try to work it out. Count will be, let's say, 16, maybe 17, 18. Yeah, 18 might work. What? 17 too? Can I do with 17? But 17 works fine. Well, let me try to sorry about that. Let me try to do this. So only 18 is the problem. What? Okay, 7 output should have been 6, but seeing something different. But there was, it's already 17, but 18 is having a problem. 18 is having a problem. Yeah, 17 is the maximum it can go. I don't think this will work. Yeah, 22, yeah. Yep. Right. Yeah, let's try to, yeah, so my ranking is gone. It's just gone. Shit. Alright, let's try to analyze. Right. This was weekly contest 178 what was it, 482. Let's directly try to see the approach of C. Is this C? Yeah.
If this for loop current value is I, then this P variable is okay. So this problem is called smallest all ones multiple. You are given a positive integer k. Find the smallest integer n divisible by k that consists only the digit 1 in its representation. Okay. Return an integer denoting the number of digits in the decimal representation of n.
It's literally so small code. How?
If no such n exists, then return -1. Okay, so what they are saying is, we have been given an integer k. Okay. We want to find out the smallest possible n. Smallest possible n such that it is of the form 1 1 1 1 1 1 1 1, like 1 1 repeated d times. Okay. So we want to find out that the smallest possible number n, which is 1 repeated any number of times, that is either 1 or 11 or 1 1 1 or 1 1 1 1 and so on. We want to find out the smallest possible number which is a multiple of k. Okay.
Yep.
It's like basically the remainder of n modulus k should be equal to 0. So we want to find out what is the smallest possible value of n, and if there is no value, then we have to return -1. Like we have been given this k, and we have to determine that what is the smallest possible value of n. Okay. So how do we actually do this? Like essentially what we want to do is, we want to find out the smallest d such that this number 1 1 1 1 up to 1 1, this d times this should be multiple of k.
Yeah.
This should be a multiple of k, right?
Yes. Correct.
So like, how do we determine that what is the value of d? So actually this is a kind of mathematical problem. Okay, like because you can't really try every mod. Like let's say you just try to do brute force, like you try 1, then is 1 a multiple of k? If it is, then print it, otherwise no. Then you try 11, is 11 a multiple of k? We don't know. Like is it might be or it might not be. Then is 1 1 1 a multiple of k? So if you keep checking like this, if you like just keep checking like this, then there are two issues with this. First issue is, then when will you stop? When do you stop? Because like we don't know that what if it doesn't exist? Like what if for a certain k the answer is -1? So this will run infinitely, right?
Yeah, correct.
And the second issue is that as soon as you hit
many
number of ones, like as soon as you hit 60 ones, let's say, or not even 60, let's say 20 ones you hit. Okay, so it will be approximately 10 to the power 20 or 10 to the power, okay, let's say if you hit 21 ones, okay, so it will be 10 to the power 20, and this is out of the range of long, right? This is not inside the range of long, so you cannot really check any numbers which are greater than 10 to the power 20. So you have to stop there.
Okay.
Like, but it might be possible that what if a bigger number is a multiple of k, right? Like in the samples they have given.
Yeah, that was exactly the problem.
So there is not any sample which is
that
having
we
a
fall because we didn't think too much. This is the problem that we have faced because of not thinking too much. So let's see
high answer.
how we can actually.
But still, there might be some k. There might be some possible k for which the answer is a very big, like maybe 21 ones. 1 1 1 1 21 times. So this does not even store in long. So you cannot even check that this number is a multiple of k or not.
Yeah.
Right. So the brute force approach has these two problems. Right. Like you cannot just do it naively. Alright?
Yeah,
You have
yeah.
to think of some other patterns. Okay?
Correct.
That is the issue in this problem. Alright. So let me reiterate the problem. You have to find n which is 1 1 1 1 repeated d times. Okay. Such that this is a multiple of k.
Yes.
Multiple of k. So basically we want that n mod k, that is remainder of n when divided by k, is equal to 0. Okay.
Yep.
Now what I am saying is, what if we would try to write this n in terms of some expression? Like this 1111 d times is not very helpful. So let's try to make it kind of helpful to us. Okay. So you can write this number
1 times
as unit
d.
digit 1 plus 10 digit is 10 to the power 1 plus
Yeah.
10 to the power 2 plus 10 to the power 3 up to 10 to the power d minus 1. Right. So this is a GP. Okay. This is a GP of having common ratio equals to 10 and number of terms equals to d and starting term is equal to 1. So if you apply the formula for the sum of GP, that is
Alright.
a into r to the power number of terms minus 1 upon r minus 1. So this will turn out to be 1 into 10 to the power d minus 1 upon
Oh shit.
10 minus 1,
Damn.
which is 9. So basically you have 10 to the power d
Shit, man. Okay, I couldn't think this. GP.
minus 1 divided by 9.
Never really thought
Okay.
about this.
So this number, like 1111 repeated d times,
GP
is the same as
Okay.
10 to the power d minus 1
Right.
divided by 9. Right. So we want that this number n which is 10 to the power d minus 1 divided by 9, this number has to be divisible, like mod k should be equal to 0.
Yeah, yeah,
Okay.
correct.
So we want
So
that this number,
we have to do
which is
something
10 to the
about
power
this
d minus
thing.
1 divided by 9,
This
has to
thing.
be divisible by
Okay.
k, that is
Okay.
its remainder mod k
Right.
should be equal to
Right.
0.
Right.
Or we can say that 10 to the
Okay.
power
Right.
d
So
minus
we
1
have to think
divided by
about
9
this.
has k as a factor.
Yeah. So what we can think about this is basically if we have 10 to the power d minus 1 and 9, so this should be divisible by k. So k must. So this particular thing must be divisible by 9k, right? So 10 to the power d minus 1 should be divisible by 9 times k. And okay, so when can it be divisible by 9 times k is what we need to find out. And if we try to find out 10 to the power d, then we need to think something. Yeah, so let me think it from here. So yeah, the GP is the thing that we needed to think out for a long time, like, right? So 10 to the power d is just a bunch of tens, and I am just going to divide it by 9 times k. So there's it's just going to be a lot of nines, and it's just the same thing. So 9 times k. Okay, 9 times k should. Okay, so if I try to think like this, like if the whole thing is divisible by 9k, then this particular thing should also be divisible by 9k, and this particular thing should also be divisible by 9k, or is it not something like that? Because it is not necessarily something like that. Yeah, not necessarily, right? If you are divided by 9k, then it's not necessary that this will also be divided by 9k, and this is also going to be divisible by 9k. Yeah, so what can we do? What can we really do? Bunch of nines with 9 times k. It's just the same thing again. Like I not. I did something interesting. Let's try to like. This must be a factor that this guy has seen.
Right.
So, yeah.
Factor. Okay. So what does that mean? That means that this number 10 to the power d minus 1, 10 to the power d minus 1 has 9k as a factor. Has 9k as a factor.
Yeah.
No?
Correct.
Can't you see this? Like if this 10 to the power d minus 1
Yeah.
upon
I
9
just said that.
has k as a factor, then basically, like, let's say this is capital N. So n upon 9, capital N upon 9 has k as a factor. So if you think about it, capital N must have 9k as a factor. So that when you divide by 9 also, because 9 goes away, but still k is there. K is still there, right? So capital N must be a multiple of 9k. Okay. So basically 10 to the power d minus 1 has 9k as a factor. What? So that means that the remainder, if I divide by 9k, must be 0. So like
okay,
10 to the power d minus 1
right.
modulus with 9k
Yeah, this is
must be equal to 0.
this is correct.
Right. So we can say that the 10 to the power d, if I like modulus with 9k, must be equal to 1. Right. This is the condition that we want.
What?
Such a
If 10 to the power d minus 1 modulo 9k is 0, then 10 to the power d modulo 9k is 1. Yeah, you are correct.
d, we want a d such that 10 to the power d modulus 9k should be equal to 1. Right, this is the entire condition.
Yeah, so like I could have never thought this, man. Like, come on. I could have never think.
So we can simply try d. Like again, like now the problem 2 is eliminated. Like what I was saying is the problem 2 was that our numbers were becoming too big. Like if we just see that 1111 21 times, that will still not fit in the long range, right? So what we have done is we have simplified the expression, and we have found out that 10 to the power d modulus 9k should be equal to 1. That is the condition. So we have to find such a d. Now what we can simply do is we can iterate from d is equal to 1 to, like, okay, let's say we iterate from d equal to 1 and onwards, and we keep incrementing d, and we can simply find 10 to the power d modulus with 9k. Like see, in the some PNC problems or in DV problems, they tell you, right?
Yeah, I got
They
what
tell
you're
you
trying to say.
to find the answer.
Yeah, like you're just going to already you're like 10 to the power d and okay, yeah. So basically what you're trying to do is multiply d and always do modulo 9k. Try to do multiply d again and multiply 10 again and try to take 9k such that only the remainder exists. Yeah, this was no way I could have thought.
Or in DV problems,
Yeah.
they tell you, right? They tell you to find the answer.
I mean, maybe I could have think about if like if I had some more time, maybe if I like if I try to solve this, maybe not in a contest, maybe I would have solved it, but it was in a contest. I think I wouldn't have solved this. I
Because
wouldn't have
modulus 10 to the power
thought
9
this,
plus 7.
even if I knew a lot of
Right, they tell
mathematics.
you like this.
Yeah, I know this. What
Yeah,
you're trying
iterate
to
from
say.
d equal to 1 and onwards, and we can like find out the value of 10 to the power d by taking mod with a 9k every time.
Yeah.
And if it becomes equal to 1 at any point,
Yeah.
then we return that d.
Correct.
Okay.
But how
So
do you
like for
know
example,
if it is not? So you are just going to check for all int min.
we
or
have k
what?
equal to 7. right? If we have k equal to 7, that means we want that 10 to the power d has to be like 10 to the power d minus 1
Yeah,
upon
okay,
9
so the
has to be a
remainders, I think
multiple of 7.
remainders.
So 10 to the power d minus 1 has to
As I know, remainders tend to repeat itself or
be a multiple of
something like
63.
that. But like you won't have. Yeah,
So
I don't know.
10 to the power d modulus 63 should be equal to 1. So like let's try for d equal to 1. If d is equal to 1, then 10 to the power d is just 10, and if I take mod of it remains 10, so it is not 1, right? Then for d equal to 2, it is 100, and mod 63 is 37, so it is not 1. Then for d is equal to 3, we can multiply this 37 by 10, so it becomes 370. But 370 mod 63 is what? Let me use Python for that. 370 mod 63 55. Okay, so it becomes 55, and it is still not 1. Then for d equal to 4, it is 550, and if we take mod with 63, so 550 mod 63 is 46, still not 1. Then 460 mod 63 19, and 19 mod 63 becomes 1, right? So basically at d equal to 7, your 10 to the power d, basically I can show you like 10 to the power 7, 1 2 3 4 5 6 7. If you take mod with 63, sorry, not 7, 6, the answer is 6. Okay, so d equal to 6. If you take 10 to the power 6 modulus 63, that is 9k, you will get 1. Okay, 1 2 3 4 5 6 mod 63 is 1, right? So we can say that 1 1 1 1 1 1 6 times is a multiple of 7, right? That is the condition. So finally the condition is just that 10 to the power d modulus 9k
Right.
must be equal to 1. So like our mod is 9k, and we have to find out the value of 10 to the power d modulus 9k, and just find out the value which is 1, right? But now the problem is still there, a problem that when do we stop? Like how
Yeah,
do we know
correct.
if it exists or not? Like how do we know if a number such that 10 to the power d is 1 exists or not?
Yeah, so yeah, if it repeats itself again, then we can say that it does not exist, right? So yeah, if it yeah, so in order to repeat itself, you're not going to take like another 10 to the power 5, correct? Because if k is at most 10 to the power 5, then you can just check for 9k minus 1 till 9k minus 1. Try to do all the possible things that you can and try to see if everything you have done is gone or not,
A number d.
or something like that.
Like when do we stop? That is still the problem. So the point is that if you take mod, then eventually a cycle will be there. Okay.
Yeah, that's what
Like,
I just
for example,
said.
if my mod is 7, let's say, if my mod is 7,
Because after when you multiply it by that number again, then you are going to get the next number previously which you got. You're going to get the same number. How do I explain? Like for example, if you have 2 and the remainder is 3, and suddenly you got 2 again, then after multiplying it by that thing, you are obviously again going to get 3, right? So there will be a cycle, and in order to the cycle is obviously not going to be more than 9 minus 9k minus 1, right? It can be like something like 0, 1, 2, 3, 4 and 9k minus 1 and then again hit cycle. So at the 9th gate time it hit the cycle. So it cannot hit the cycle more than that, right? You either you find in that particular thing or not, because cycles are like it's going to be less than the obviously maximum remainder cycle that can happen is 0 to k 0 to r minus 1, which is the remainder, right? So now the cycle is only going to be a subset of these things. So at max, what is going to be the subset? The full subset 0 to r minus 1. So just check for all of the values from from d until, so you can just check from d to 1 to 9k.
Say I'm trying
That's
to
what
find
he
out
actually
10 to the
did.
power d value.
And now I understand. Like this was
By
very like elegant thing actually. Like I think I got how to do this. So let's say this. Okay, so basically I have d equals to let's say initially I have d equals to 0 and I have x equals to 1, right? And I have to just for anti I equals to 0, I is less than 9 times k, I plus plus, and what do I do? Well, this is x, this is going to be the d, right? So let's change it, the variable name to d. So d is initially 0 and okay, alright, what am I doing? Yeah, so d is initially 0. Yeah, so what will I do? I'll you have this one, and yeah, x times yeah, so if x modulo 9 times k is equals to 1, then return d, correct? D plus 1 maybe. Yeah, you checked for 0, right? Else what you do is x equals to x times 10, right? And you just do modulo 9 times k and you try to find this, and you do this till this thing, and if you don't get, you just return minus 1. Yeah, this should work, hopefully. It didn't work. Okay, what? Next time. Yeah, so x is obviously it's going to be, yeah, it should be a multiple of 9k. So it should be at least as big as 9k, right? Like d should be greater than, so I need to make k greater, x greater, right? So I need to make x greater at first. So 10 to the power something modulo k. Yeah, so the problem is I need to start x from k, correct? From 10 to the power something which is already greater than k. So maybe I can just use another for loop. So that this becomes greater than 9k maybe. It has to be greater than 9k, right? Because 111's the GP should be greater than k, greater than or equal to k, and the mod should be this. So it should be greater than 9k. Yeah, it should be greater than 9k. So first of all I want it to be greater than 9k. So while x is lesser than 9 times k, x times equals to 10. Yeah, I do this, and when it becomes equal or more than 9k, then I try to do this, and I hope this will work. It still didn't work. Why? Yeah, because the D is actually D plus plus. Here I am going to be like, okay, anti-count equals to 0. So 0 less than, let's say, you don't need to check for more than this count, and then I will count plus d, right? If I see that this d is working, then we do that. Yeah, so first d is 0. I think this will work. Either, okay. It did work. So yeah, it was a hard question, to be honest. For me it's hard. It's not easy. Not this one. Let me do this. Yeah, this question, it was hard, and my solution is really very bad because I'm doing this thing. Just bad. Okay, anyways, yeah, so that's it for today's video. Yeah, bye bye.